Welcome to the training module on contouring tools for 4D planning in Eclipse version 13. In the previous training module, the breathing trace was imported into Eclipse using the DICOM import-export application. 4D CT images may also be imported into Eclipse using either the DICOM import-export application or the file import wizard within the selection workspace. Eclipse will automatically generate the 3D volumes of the binned images and create the 4D volume image encompassing all the binned images. If the file import wizard from the selection workspace is used, then the body contour can also be automatically generated for all 3D images in the 4D volume image. Once the 4D study set has been imported in, select the contouring workspace. There are a number of methods available to create 4D plans, and these may vary depending on the individual clinic's process. In this training module, the gross tumor volume will be outlined on all phases first to determine the amount of tumor motion using the volume statistics tool. The breathing trace and statistics tool can assist in determining whether motion management should be used and which phases of the respiratory cycle should be used for gated treatments. An average image is created using the selected phases for treatment. The gross tumor volume from the selected phases is then accumulated onto the average image. The patient's respiratory motion may be reviewed to determine the stability of the patient's respiration and the patient's suitability for motion management. To access the breathing trace, select the 4D menu option and then select the respiratory amplitude distribution. The 4D image may also be viewed in a movie sequence by selecting the 4D menu option and then select Play 4D Image. The movie player appears at the bottom of the screen. You may blend the CT with the PET 4D volume if it exists. To initiate the movie, select the Play button. To keep the movie loop going, select the movie loop icon at the end with the arrow on it. Once the review of motion is complete, click on the button that says Close Player. Now select the one phase that has the least motion to delineate the gross tumor volume. In this case, I have selected the 50% phase. Right mouse click on the image and select New Structure. Select the appropriate tumor ID and appropriate tumor type. Use the contouring tools to draw the gross tumor volume. After delineating the gross tumor volume, propagate the gross tumor volume to all phases. To do this, select the gross tumor volume so that it is bolded. Go to the 4D menu option and select Copy Structures to Other Phases. Select the gross tumor volume and then select either rigid or deformable propagation to all the other phases. Deformable propagation is only available when either smart segmentation or smart adapt licenses exist. If the decision in motion management has already been made and the phases already selected at the RPM system, then propagate only to the phases selected. Review the propagated structures on every slice of each 3D binned image and edit as necessary. Note that Eclipse version 13 has some new 3D contouring tools such as the Transform and Deform tool that may be useful in making these edits. Once the gross tumor volume has been edited and reviewed, navigate to the 4D menu option and select 4D volume statistics. The volume statistics dialog box opens. Select the center of mass for the type and select the gross tumor volume under structure ID. A graphical representation of the tumor motion is displayed in the X, Y, and Z directions. The statistics can assist us in making a decision on tumor motion management and choosing the most stable phases for gated treatments. In this case, I will select phase 40, 50, 60, and 70. To create an average image from the selected phases, navigate to the 4D menu option and select Create Average Phase Image in 4D CT. Select the phases to be included in the average image, in this case 40, 50, 60, and 70, and then select Mean and give the image an ID, such as average 40 to 70, and then select OK. To accumulate the gross tumor volumes from the selected phases onto the average image, go to the 4D menu option and select Create Accumulated Structures in 4D Image. Select the structure to be accumulated and the selected phases. And then select the average image. And then select OK. Give the accumulated gross tumor volume an ID and then select OK. Right mouse click on the accumulated structure and change the color of the structure by going to Properties. This will help us distinguish it from the other gross tumor volumes drawn on the 3D image. Now play the 4D movie by going to the 4D menu option and selecting Play 4D Movie. And we will blend the 4D image with the average image. This will validate that the accumulated tumor volume does indeed encompass the tumor in the selected phases. To validate this, right mouse click on the gross tumor volume that was accumulated and select Move Viewing Planes to Structure. Now move the blend slider all the way to the CT to display the 4D CT image. And now movie through selected phases to validate that the accumulated gross tumor volume does indeed encompass all of the gross tumor volumes drawn previously. In this case, we will scroll to the 40% phase and validate that the accumulated structure, which is in cyan, does indeed encompass the pink tumor that was drawn on the individual binned image. We carry on to the next phase that was selected and ensure that once again the cyan color does indeed encompass the tumor volume that was drawn on the individual image. Edits can be made if necessary. Further margins can be added to the accumulated gross tumor volume to create the ITV for planning. Contour the body and critical structures in preparation for planning on the average image, and then continue on to external beam planning to create the plan. This concludes the training on contouring tools for 4D planning. The next training module will address an alternate workflow process of creating a maximum intensity projection image and delineating the gross tumor volume on the MIP image. Thank you for your attention.